Hello guys, welcome on Tesla Adventures. In this video today, we'll be discussing the problems from Irodov which are based on projectile motion. So let us discuss this first problem. You can see that there are two bodies which are thrown simultaneously from the same point. One is projected in the upward direction with a speed v0 and other one is projected at an angle of 60 degree. Okay, and we have to neglect the air resistance. So now we have to find out the distance between these two bodies after 1.7 seconds of projecting them. So we know that, let's suppose v1 is equal to v0 j cap and v2 is equal to v0 cos theta I cap, which is cos 60 is half, as well as v0 sin 60 is root 3 by 2 j cap. Okay, so let us solve this problem in the relative frame. So v2 minus v1 is equal to, or v1 minus v2 is equal to v0 minus v0 j cap I cap by 2 and plus v0 minus v0 root 3 by 2 j cap. So this is v relative, and v relative magnitude will be equal to under root of 1 plus 1 minus root 3 by 2 whole square into v0 by 2, which is common. In fact, we can take out v0 by 2 common, and it would be 1 plus 2 minus root 3 whole square. Okay, so, and the distance, now you can see that in the relative frame the relative acceleration is 0, which means that relatively they will be moving with constant velocity in a straight line, and therefore we can write down this velocity as displacement upon time. Okay, so displacement will be equal to v relative into time. So you can see that it would be v0 by 2 into time t under root of 1 plus this is 4 plus 3 minus 4 root 3. So it would be v0 t by 2 under root of 8 minus 4 root 3, and you can take out 4 common, so it would be v0 t under root of 2 minus root 3. Okay, so this would be the result, and if you will substitute the value of v0 as 25 and the value of time as 1.7 seconds, then this distance s would be equal to 22 meters. Now we move on the next question. In this question, you can see that the radius vector of a point relative to the origin varies according to the time like this: r is equal to a t I cap minus b t square j cap, where a and b are positive constants and I and j are the unit vectors along x and y axis. So the equation of this point trajectory, and we have to plot this function. So we know that r is equal to a t I cap minus b t square j cap. So what we can do, that x is equal to at and y is equal to minus bt square. So time is equal to x upon a. We can substitute the value of time. So y will be minus b x square by a square. So this is y, and this is a parabola which is opening in the downward direction. So this parabola would be in the fourth quadrant, and its base would be at origin. So it would be like that. And we have to find out the time dependence of velocity and acceleration vectors and the magnitude of these vectors. So we know that r is equal to, this is B, question number B, r is equal to at I cap minus bt square j cap. So v vector will be dr by dt, and dr by dt would be a I cap minus 2bt j cap, and the mod of v would be under root of a square plus 4b square t square, while a vector would be equal to minus of 2b j cap, and its magnitude will be plus 2b. Now we have to find out the time dependence of angle between vectors w, which is acceleration, and v, which is velocity. So we know that the angle between these vectors, let's suppose this is a vector and this is, and obviously you can see that a vector is in minus j cap direction and it is two dimensional. So you can see that if we draw, we can see that a velocity is in fourth quadrant and acceleration is in negative y direction. So this angle theta, tan theta, would be equal to the x component of this velocity vx and the y component of this velocity vy. So vx is a and vy is 2bt. So this is the time dependence of this angle between velocity vector and acceleration vector. And in the d part, we have to find out the average velocity averaged over the first t seconds of the time. Okay. Now if we talk about the average velocity, then average velocity would be equal to the position vector, change in position vector upon time taken. So we know that at t is equal to 0, position vector was 0, obviously you can see and at t time it is this one. So this average velocity would be r by t, and hence it would be a I cap minus bt j cap. This would be the average velocity, and v average magnitude will be under root of a square plus b square t square. Now we move on the next question. In this question, a ball starts to fall with zero velocity on an inclined plane from a height h, like that. This is h and this initial velocity is 0, and when it falls on the inclined plane, then it rebounds elastically. So we have to find out this distance after which the second collision will occur. So obviously, first of all, we know that this velocity is V, and V would be under root of 2gh. And we know that after collision, the component of velocity in the perpendicular direction will just reverse itself, which means that this component, initially we know that this angle is alpha and this angle is alpha. So this component is V cos alpha, and the component parallel to the inclined plane is V sin alpha. So we know that V sin alpha will remain as it is, and this is V cos alpha, and it would go like that. Okay, so the time of flight would be 2V cos alpha divided by G cos alpha. So time of flight would be equal to 2V by G, and along this direction the range which we have to find out is equal to ut. Now this is V sin alpha, which is the velocity along this direction, and time is 2V by G plus half at square. Now acceleration in this direction is G sin alpha. So this is G sin alpha into t square will be 4V square by G square. Okay, so this range, you can see that it is 2V square sin alpha by G plus this is 2V square sin alpha by G. So it would be equal to 4V square sin alpha by G, and the value of V is equal to, range is 4V square sin alpha by G, and the value of V is equal to under root of 2gh. So range is equal to 4 by G into 2gh sin alpha. Cancelling this G, so it would be 8h sin alpha. Now we move on the next question. In this question, you can see that a particle is moving in such a way such that its velocity is given by ai cap plus bx j cap, where x and y are the coordinate axis and a and b are constants, and initial moment a particle was located at origin. So we have to find out the equation of trajectory of this particle as well as the radius of curvature of the trajectory as a function of x. So we know that Vx is equal to a and Vy is equal to bx, and Vx is dx by dt, which is a, and Vy is dy by dt, which is bx. So you can see that dy by dx is equal to bx upon a, and dy is equal to bx dx. So integrating both sides, we can see that integration of this would be 0 to y a, and integration of this would be x dx, and this is dy, limit would be 0 to x. So it is a y and it is bx square by 2. So y is equal to bx square by 2a. This is the equation of trajectory, and the radius of curvature as a function of x can be calculated by the fact that we know that r is equal to 1 plus dy by dx whole square to the power 3 by 2 upon d square y by dx square. So r will be equal to, now we know that y is equal to bx square by 2a. So dy by dx will be equal to bx by a, and d square y by dx square will be equal to b by a. So it would be 1 plus b square x square by a square to the power 3 by 2 upon b by a. So radius of curvature is a by b into 1 plus b square x square by a square to the power 3 by 2. Now we move on the next question. In this question you can see that there is a cannon which is fired on a target, and the target is at a distance of 5.1 kilometer from the cannon. Now they are at same level, and we have to find out that how soon would the bullet strike the target. So we know that the range is 5.1 kilometers, so the range is 5100 meters, and this range is equal to u square sine 2 theta by g. Okay, so this g is 9.8 and u square is 240 into 240. So this is sine 2 theta, and this would be equal to approximately sine 60. So 2 theta is 60 and theta is 30. So we know that there are two angles for which range is same. So the other angle would be 90 minus 30, which is 60. So the time of flight will be equal to either 2u sine 30 by g, or time of flight will be equal to either 2u sine 60 by g. Okay, and in both these cases the time of flight would be either in this case it would be 0.41 minutes, and in this case it would be 0.71 minutes. Now we move on the next question. In this question you can see that a cannon fires successively two shells with velocity v0 is equal to 250, but both shells are fired at different angles. First one is fired at 60 degree with the horizontal, while second one is fired at 45 degree to the horizontal. Okay, now we have to find out the interval of firing so that they collide. So let us draw the trajectories. So let us see that if this is the shell which is fired at 60 degree like that, and the shell which is fired at 45 degree would attain a lower height, but range in 45 degree will be maximum. So these two are coinciding, these two trajectories are intersecting at a point. So at this point they will collide. Therefore let us write down the equation of trajectory for first one. So it is y is equal to x tan 60 minus half gx square upon u square cos square 60, and this would be equal to x tan 45 minus half gx square upon u square cos square 45. So this is x into root 3 minus this is 2gx square by u square, and this is equal to x minus g x square upon u square. Okay, so you can see that x root 3 minus 1 is equal to gx square by u square, and cancelling x with x. So this x is equal to root 3 minus 1 u square by g. x is equal to root 3 minus 1 u square by g. Now this x is same for both of the shell, but the time in which they will reach at this point is different. So let us suppose that the firing difference, the difference of the time in which they are fired, so that would be the difference of the time at which they would reach at that point. So let us suppose that the first shell reaches that point. So the time of the first shell would be x upon ux, which is u cos 60. On the bigger value of theta, cos theta will be lower and therefore time would be higher. So delta t would be equal to x upon u cos 60 minus x upon u cos 45. So x upon u is common, it would be 2 minus root 2. So x is equal to root 3 minus 1 into by g, cancelling u with u, this is u and this is root 2 minus root 2. U is equal to 250, so let us use u 250 and g as 9.8. so this time would be approximately 11 seconds. So there should be a difference of 11 seconds between the two successive firings, so that both shells intersect and collide at a point. Now let's move on the next question. In this question, you can see that a particle moves in xy plane with a constant acceleration w directed along negative y-axis, and the equation of trajectory of this particle has a form y is equal to ax minus bx square. So y is equal to ax minus bx square, and we have to find out the velocity of the particle at the point of projection. So we know that tan theta, we know the general form of the equation, y is equal to x tan theta minus half g x square upon u square cos square theta. So if we compare this equation with this one, so tan theta would be equal to a, and therefore cos theta would be equal to 1 upon under root of a square plus 1, as well as sin theta would be equal to a upon under root of a square plus 1. So if we compare these two equations again, then g by 2 u square cos square theta is equal to b, and u will be equal to g upon 2b, u square will be equal to g upon 2b cos square theta, where cos square theta is this one, so it is a square plus 1. So u will be equal to under root of g into a square plus 1 by 2b. So this is the velocity of the particle at the origin, and the angle of projection is this one. So if we write this velocity in the vector form, then it would be u cos theta I cap plus u sin theta j cap. So this would be equal to under root of g by 2b I cap plus a under root of g by 2b j cap. Now let's move on the next question.